Okay. Is it recording? Okay. I think it's recording. All right. Yeah. Okay. All right. Sweet. Okay. So I'm gonna get started. Basically, we're gonna learn how to use ANSYS today. And if you don't know what ANSYS is, it's just basically, I'd argue, it's just basically a meshing software that can carry out complex calculations. And so within ANSYS, there's multiple things that you can do. But today we're just going to focus mainly on analysis. So like finite element analysis. And finite element analysis is basically the study of, you have a structure, you put it in, you define the materials, you define the forces that it's going to take, and then it just spits out how the structure is going to deform under those loadings and whether it's going to fail or not. And we'll get there. So in order to get there, there's like a lot of intermediate steps. And sometimes the computer just doesn't want to do it. So you have to like go through all of them and assign them yourself at times, right? So today we're just going to look at basically how to access ANSYS within the context of use-day racing, as well as how can we set up the model to be analyzed, right? So first, you need this program called TeamViewer. So as you can see, it's on my screen. And in order to access, and this gives you basically a screen share into our virtual desktop into the computer that we have in the use-day racing room workshop. So this is a partner ID, which we use to connect. And then once you connect, it will ask you for a password, which is because race car. Okay, so I'm gonna put that. So if you don't know what it is, let me put, there's no pen. Okay, so password is because race car, right? So yeah, just remember that if you want to ever use it, right? So then now that we have, then once you've done it, you just essentially just want to go down and click Workbench. So Workbench is essentially ANSYS. And once you click Workbench, you'll have basically an empty screen. So you won't see any of this. So on the left over here, you'll see there's different systems here, system packs. So these are called toolboxes, which you'll just drag and drop onto your project schematic, and you will make them linked up. And through each toolbox, you input certain amount of data, and it takes that data and outputs a different set of data. And essentially, after you create a full chain, it will output the analysis that you require. All right. So today we're just going to look at two toolboxes. First is engineering data, and second is the mechanical model. So engineering data is under component systems. So if you go down, you look at engineering data, click, and then you just drag it onto create standalone project. So this is how you first start any project. You start with engineering data. This essentially defines your material properties that you're going to be using. Yeah, that's pretty much it. So in order to edit it, just double click it, and it will open up a tab. So first tab is project, second tab is engineering data. So when you open that up, so typically we work, so you can use any material that you want, but typically because we use carbon fiber, I'm gonna just show you how to set up a carbon fiber material. So first you wanna go to engineering data sources. So under engineering tab, there's different too, like there's another sub tab called engineering data source. You want to go to, so under here, there's a library of materials that ANSYS already provides, but they're not specifically built for what we need. So you sort of have to go in, choose the material that you want, and edit it accordingly, right? So when you go to composite materials, oh god, okay. So when you go to composite materials, you want to choose carbon fiber 290 gigapascals. So that's somewhat close to it, close to what we choose. Is everyone keeping up so far?
Yeah.
Okay, sweet. All right, just checking. All right, so what you want to do is go to carbon fiber 290 gigapascals, and then on the right side of it, there is a small little plus sign. So it says add to, if you click it, you'll just click add, and then you'll see a little book appear on the on column C. So that just means it's been added to your engineering data that you're going to be using later, right? After that, go back to, so just unclick. So if you click engineering data source and then you unclick it, you'll go back to your main window. So within engineering data, and this shows all the materials that you've chosen. So by default, there's structural steel and the carbon fiber that we just added, right? So now I'm going to click on the carbon fiber that we just added. And, oh, okay, I chose the wrong one. So you got to be careful about this. All right, so go back to engineering data source. And so basically what I chose was carbon fiber 290 gigapascals. This is just the carbon fiber alone. So if you see under description, it says fibers only. So that's my mistake. What you want to do is go to prepreg. So in this case, there is epoxy carbon woven 230 gigapascals prepreg. That's what I want to choose. So you can see the bookmark up here. So there's all sorts of other sorts of things. So epoxy carbon UD means unidirectional. We don't use unidirectional. So unidirectional is pretty much instead of having two 90-degree plies, it just has one continuous weave embedded with epoxy. But woven is essentially what we use, and we use prepreg. So prepreg means it's pre-impregnated. Wet means that you're doing a wet layout. So typically you just want to stick with 230 gigapascals prepreg epoxy carbon woven, right? So add that, and then unclick engineering data source, and then you want to go to epoxy woven. So I'm just going to delete this guy, and I'm just going to leave structural steel there because it's sort of easier at times, because ANSYS will automatically assign all the materials to structural steel, and then we just have to go in and change it. So afterwards, you have to look at the properties of epoxy woven. So it appears under here. So this is not exactly what we use. It is different from what we use. So in order to change the values, all you have to do is go in and just double click the cell and, for example, type in a random value. But we're not going to look. So where do you get these values? This is where you get your data sheet comes in from. So if I'm not wrong, we use Torre 2510. So this is the data sheet that Torre gave us when we got the material. So you want to go in and check what what we're using. So the data from the material that from the carbon fiber sheet that we're using. So in this case, we are using Torre 2510, and under Torre 2510, there's 3 different product formats. One is unidirectional, which we don't use. Second is plain weave, and third is glass fabric. So we use plain weave. So we're going to go to AMS 3914. So if you go down, wait, let me remember what this is. Okay, F627. Okay. So we're going to look at, so this is the, I think this is the unidirectional, and then this is the, okay, this is the plain weave. So there's a bunch of numbers here, which I'm going to, which I think I explained to you guys earlier about carbon fiber material properties. But if you want to Google them, you can Google them. And So the weird thing about ANSYS is that, so carbon fiber, naturally there's two different properties because it's a fiber. It tends to have tensile strength. So if you're pulling a carbon fiber, it's very strong, but then it also has compressive strength. So if you push a weave, it sort of collapses on itself. So in the case of carbon fiber prepreg weave, it's compressive strength, and it's, so if you look here, so okay, so also have to talk about why there's three different columns here. So CTA means ambient temperature, room temperature application means like normal room temperature, and ETW I think is like high temperature. So I can't remember, but just look at RTA for now because technically all our materials always operate at room temperature. So okay, so that's out of the way. So ANSYS has this weird thing where you are not allowed to have two different properties for tensile as well as compressive. But the good thing for a weave is that usually the compressive, so if you look here, and the tensile is roughly around the same. Well, not quite, but let's say roughly. So what I usually do is that I'll consider the lower compressive. So I'll always look at the compressive strength and type that in instead of using the tensile values, simply to add a factor of safety, right? So in this case, it's actually kind of big, but for safety's sake, we're going to assume that it's the compressive strength, all right? So let's say 0 degrees compressive strength, right? So I would go to ANSYS, and then I would go under orthotropic elasticity, and then under here it would ask me what is my Young's modulus x direction. So that's Young's modulus x direction just basically means 0 degrees, and in this case you'd use the compressive strength. So I'd go here, I'd first change the values. Okay, so right now the unit is in pascals. So yeah, that's good. And then from here I will take so it was 101 gigapascals. So I'm going to put 101 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then press enter. And then let me go back and check that. Is it gigapascals? Yes. Oh no, wait, sorry. So that's the strength. You gotta look at the modulus. So yeah. So 8.09 gigapascals. Okay, I messed that up. Okay, so yeah, so 8.09 times 10 to the power 9. So that's roughly, yeah. So you can do that for your x direction as well. And then, so we're just going to assume that, okay, so yeah, so you just want to type that in, make sure that's correct. So leave the Young's modulus z direction. Typically, this doesn't matter because when we do analysis, we do it on a laminate and not a 3D structure. So because of that, the z direction does not matter. The only things that matter are the x and y direction. So another thing that we also need to do is Poisson's ratio. So we need to go back, look up the Poisson's ratio V12 and at RTA 0.04, and then type that in. And then, so after we change all of this, we need to go to orthotropic stress limits, and that's where we get the strength. So tensile x direction will be your 0 degrees tensile strength. You type in 132 megapascal, sorry, 912 megapascals or 132 KSI. So yeah, okay, I messed up, but yeah. Oh, no wonder. Okay, but yeah. So you just have to keep note of all the limit of the units they use, and be extremely careful when you type it in. And then you have to I usually get someone to double check with me after I type in all the values, just to make sure that I am not crazy. Right. So after you type in all the material properties, um, then you're pretty much good to go on this side. And then you can close entering data and then update your project. All systems are currently up to date. So in this case, I don't care about this. I'm going to delete this. And yeah, okay. So I've already uploaded the entering data. And so now I'm going to move on to mechanical model. So mechanical model is where your first structure comes into play. All right. So so it's pretty time consuming to key in multiple engineering data sources. So the nice thing is that you can use this one engineering data source and project it out to a bunch of other mechanical models. So for example, within the same project, you can analyze a seat as well as the wings because you're using the same carbon fiber weave. So that way you don't have to keep repeating yourself with engineering data. But just make sure that you always save it and update your project regularly as you go. So in order to update project, you just click up here. There's a button called Update Project, and that'll make sure that all the changes made upstream will propagate downstream. So this is upstream, this is downstream. We're just propagating it downstream. All right, so in this case, we want to go on to mechanical model. So under component systems, you want to go to mechanical model, click, and then once again, drag. So instead of creating a standalone system, what you want to do is drag it over entering data. And this will, and then you'll see a button called, a red box pop up called share A2. So that just basically means that A2 is the entering data that will be propagated into mechanical model. So, and then voila, you see the line linked to entering data. So whatever entering data the mechanical model gets will be from the box A1. And this is box C, yeah, A2 or whatever, or C, yeah. So after you've done that, what you want to do next, so entering data is good, you see the green tick, that means you're good to go. But then after you go to the next one, which is number 3, geometry, you see a question mark. So that means you have to update this model. It's not been defined yet within the context of this project. So what do? Is right click it, and then you go to import geometry. And usually you have to browse it. So you have to browse, find the object that you want to do. So in this case, so ANSYS has this update where you can now use solid part models. So you just go browse the solid part model and then just press open. And then it'll come with a green tick. So that means the geometry is successfully imported. So now what you need to do now is you need to edit this according to what you want. So this involves usually extracting the surfaces from the object, because you usually want to import a 3D model. But in the case of carbon fiber, it's a laminate, so we only want surfaces to build up off of. So we're going to look at that. So until now, are there any questions? Everyone's good? Yeah, how do I see the... Okay, I'm going to assume everyone's good. Yeah. All right. Okay, so after you imported everything, okay, you want to right-click geometry, and then it'll open up like a selection tab, and then you want to click on Edit Geometry in Space Claim, and it will open up like a sub program called Space Claim. Okay, so once you open up Space Claim, so in this case, we're just doing a simple flat panel. Um, and once you can see that there's a thickness associated with it, as well as the flat panel, like the surface of it. So what you want to do is click on the surface and then press Control C, Control V. So you can see on the design tree, the structure to the left here. After I did it from a flat panel object, which is indicated by a green box, you have a surface which is indicated by a open, like, purple surface. So right click flat panel and delete it because we don't need that solid surface anymore. And now you just have the surface that you're going to be working with. Of course, this is highly simplified. We'll go into complicated structures later, but for now, this is just the idea to get you used to the flow of how it goes, right? So one thing that you can do within these surfaces, so assume is if you want to split up the surface. So why do you want to usually split up a surface? Processing is very intensive on the computer, and usually you want results, and usually you want to try and minimize the workload on the computer so that you can get more accurate results, as well as the results output like in a faster manner. The way we can do that is by splitting up the geometry into, so for example, let's say that you have a mounting hole. So typically around mounting holes, the stresses tend to be higher because it's a circle, it's a hole, and holes tend to be stress concentrators. So you want to analyze that more in detail. But then for the rest of the flat panel, it's not really that important, right? Like all they do is pretty much propagate the stresses across from one end to the other end. And you can usually get away with making the meshes slightly larger. So that way there's less resources used. All right. So that's where you come in with split. So in this case, you want to go up here and select split under design tab and click on the face that you want to split, and then you can choose to split it accordingly. So let's say, so this is usually a rough split. So let's say there's a hole here, you just want to split it according here. So you don't have to get too crazy. That you can adjust the percentage along the line of how much you want to split. So I can split like that. And if I want to split this surface, this space again, I can choose, or I can just type in 20% and press enter, and it'll split 20% along this line. All right. So once you've done splitting and processing your geometry, you're pretty much done. You can just close space claim, and the model here will update automatically, but it's always a good idea to click on update project, and then you wait for it to update on its own. Yeah. So this usually takes a while. Oh. Okay, so now it's updated. You can see because you don't have the waiting icon anymore. So after you're done with it, you'll see a green tick come out and it'll be SC. The box will turn to a SC inside, which means service claim. This basically means that the geometry has been imported and has been edited in space claim successfully. All right. So now after that, you want to go to model. All right. So in this case, I already made one, so I'm going to click on that, and this will open up ANSYS mechanical. All right. So you can see the same flat panel, but I split into 4 different quadrants. All right. So first thing you want to do is go to geometry under sys surface. You want to click on it, and then it will ask you okay, after thickness mode. What? Okay. All right. So you want to open up the So under definition, subtab, there's one thing called thickness. All right. So usually you want to edit this. So in this case, I'm working in metric. So my default unit is meters. You can change it to whatever. If you want to work in millimeters, go for it. All you have to do is go down here and click on what unit that you want to use, unit system that you want to use. So in this case, I'm going to stick to metric because I'm comfortable with that. So in this case, so how do you know what thickness you have? This at this stage, it doesn't matter. You can type in whatever value you want, but just don't make it thick. Keep it as, so usually I just type in a nonsense value of 1 millimeter. So in this case, 0.001 meters. And I just press enter and the value comes out. After that, you want to go down, and for the material, it'll automatically default to what? Screw this. Okay. Anyways, we'll be done soon. Okay, so go to structural steel. What you want to do is you want to change it to epoxy carbon woven. So remember that we chose this earlier. We're going to click on that, and it will change it to epoxy carbon woven. All right, and after that, that's all you have to do for your geometry, and that should be good. So all you have to do now is go to mesh. All right. So mesh, in this case, I've done like a few meshing already. So I'm going to delete this meshing. Okay. So I'm clicking delete basically. So under mesh, it will come out as empty. All right. So what you want to do is right click mesh, go to insert, and sometimes if you're feeling lazy, you can just click method, and it'll pretty much just automatically generate the mesh for you. And then you click on generate mesh, and voila, there's a mesh appeared. So sometimes it's not a good idea. As in, usually it's a good idea when you're doing a rough mesh and you're just trying to get some results out. But I like to keep this as my like basis, because ANSYS mesh, like the automatic mesh, is pretty good on its own. But when I want to make the mesh slightly smaller, then I'll go in and start editing mesh. So how do I do that? So first is I have the automatic method. After I've created the automatic method, I just create mesh. And also, so under automatic method, you want to always choose quadrilateral dominant. Okay, simply because it's usually in mechanical models, quadrilateral meshes tend to be slightly more accurate than triangles, but triangles have a better way of capturing definition. So but usually I like to go with quadrilateral dominant. So quadrilateral dominant means it just tries and breaks up the existing surface into as many quadrilaterals as possible. So squares, rectangles, trapeziums, whatever. So yeah, right. So once you're done with that, you want to go to mesh, insert. So there's different types of meshing, but pretty much if you stick to sizing, you can do whatever you want pretty easily. So first you want to choose the geometry. So let's say I want to click on this left-hand quadrant here, right? If I click on it right now, it selects the whole body. So in order to just select that, I need to go up here and select the different things. So different selection methods. So in this case, you have 4 different selection methods. One is vertex. So vertex allows you to select a point. So in this case, I'm just selecting this point. That's not what I want. Second is edge, which will allow me to select an edge. So a line up to the nearest breakpoint. So in this case, there's an intersection here, and this is the breakpoint. So I'll select only up to this edge. So you can see the selection is whatever is highlighted green. Next is face, which will just select the broken up face, so the split face. So remember what I said about mounting points, and then you created a face around it. You want to select this usually. And then next is you want body, which is the default, and just selects the entire body. So in this case, I want to select the face. So I'm going to select face. I'm going to click geometry, click apply. And after that, I want to say, I want to define element size. So usually within ANSYS, within case of formula, I've only pretty much had to use element size or there's also another option if I select an edge. So let's say I select an edge here. So apply. So it's selected one edge. You can also choose number of divisions. So you can either choose number of divisions, which means that you can split up a line into, let's say, 20 divisions, or you can just choose element size. Typically, I just stick to element size because I find that easier to control, and I don't know, it's just easier for me. So yeah, you don't have to overthink this too much. We're not doing, yeah. All right. So let's go back to selecting a face. So apply, and then let's say the element size, I want to edit it to, let's say, 1 millimeter. Okay, that's too small. Okay, actually 1 millimeter is fine. Okay, so 0.01. So what this does is essentially comes up. So remember what you said about quadrilateral? It will try its best to size the quadrilaterals according to a square of 1 millimeter by 1 millimeter. So split it up as much as possible. So the rest of the object is going according to the automatic method, but for this one, we're going to the element size of 1 millimeter, right? After this, we want to pretty much call it. So that's the end of it. So we're gonna generate mesh, and so remember, this is the purple one, is the old mesh. We're gonna see how it changes. So usually this part takes a while. So the generate mesh you can see is so if you can see here, generally the outer edges where the automatic method was left alone, pretty much left unchanged with some slight changes. And then as you get here, you can see that it changed a lot. So the interesting part to notice is that at the border. So what happens here? Okay, so this happens usually, and you want to try and minimize this as much as possible. So that's where your edge mesh comes in. So for example, if you know that it's 0.1 millimeter, right? So okay, let me see whether I can annotate. Oh no, this is okay. So when you have a node, right? So when you mesh, you're essentially generating nodes. You're not generating squares. So let's say this is a square, right? So what ANSYS does is it generates the node here, the node here, the node here, the node here, and then tries and connects all of these nodes in a smooth line as possible. And when a force is acted on one node, how does that force transmit to the second two nodes, or the other four nodes that it's connected to? And so there's another node here and another node here. Okay, so that's typically how you work. That's how usually ANSYS computes. So usually you want to try and make all these nodes as perpendicular as possible to each other. So in this case, you can see it's very perpendicular here, but at the boundary, like the boundary conditions where two different types of meshes meet, you want to try and reduce this, how they mesh together. So in order to do that, what you do is you go to mesh, and you can create insert sizing again, and this time you'll select the edge, and then you can say select element size. You can put it as 0.01, and then yeah, okay, and then you can generate mesh. So it's sort of gotten slightly better, but because it's kind of a weird flat panel, usually you try not to have like such a drastic decrease in size. But yeah, it's slightly better, I think. So you can see that it's sort of gotten bigger and longer over here compared to over here. It's smaller and the sizes are slightly weird, but they also started putting triangles in there. Okay, but yeah, so usually you want to try and gradually decrease the mesh size, but usually in my opinion, it doesn't really matter that much. But yeah, it's a good practice to do. All right, so with this, does anyone have any questions? Because I'm gonna stop here, all right?